Hello friends, let's discuss about the brushless DC motor. The structure of brushless DC motor. Here in this diagram you can see this is the stationary part which is called as the stator, the shaft. On the shaft the same stator and the rotor are connected. The rotor is of permanent magnet type and at the end you can see the Hall sensors. There are three Hall sensors which are separated from each other by 120 degree from each other. Now next is the stator. The stator has a stack steel lamination type of construction that you can see in this diagram. The winding is distributed type, and because of this trapezoidal distributed type of winding, we get a trapezoid type of back EMF in the brushless DC motor. Now discussing about the rotor of brushless DC motor, there are three various types of rotors are used. In this, magnets are mounted on the periphery of the rotor. Here the magnets are embedded inside of the rotor, and here in this diagram the magnets are inserted into the cylindrical rotor. This first type of rotor is used for low speed application. It is mainly because in this magnets are pasted on the cylinder with the epoxy glue. When we are saying that these are the pasted, that means at high speed there would be high centrifugal force, and because of the high centrifugal force there will be the possibility that magnets can be separated from the cylinder. These two types, embedded and inserted, they can be used at a high speed. Now about the material of the magnet. The magnetic material that we traditionally use is the ferrite type of magnet. The challenge with the ferrite type of magnet is that it has a very low magnetic density, while if we compare and use the rarer type of magnet, it has a high magnetic density. So with the high magnetic density, the advantage is the size of the magnet is reduced. However, it gives the same magnetic density. Because of the reduction of the size, the weight of the brushless DC motor also get reduced. Hence, the rotor we used are mostly of rare earth magnet type. Now, before learning how exactly the brushless DC motor works, let's discuss the motoring operation of the brushless DC motor. Here you can see the stator pole and the permanent magnet rotor. Here red color shows the north and the green color shows the south pole. So when we give positive negative supply, the north and south pole will repel each other, and because of that it will rotate a half revolution. So again, to give another half revolution, we reverse the supply, and because of the reversing of the supply, the north pole becomes south and the south pole becomes north, and again there are chances that it will move a half revolution. But we are not sure in which direction now rotor will rotate. Either it can rotate in clockwise direction or it can rotate in anti-clockwise direction. So such type of operation in which there is only one pole pair, that is only one north and one south, one pole is present, that is called as a single phase switching. In brushless DC motor, normally we use three-phase type of brushless DC motor, because of which we gauge the exact precision and control, while there is no challenge of whether the rotor will rotate in anti-clockwise or clockwise direction. So now let's discuss about the working of brushless DC motor. Here you can see A, B and C. These three windings are displaced from each other by 120 degree, while B dash is one winding, A dash is one winding, and C dash is the one winding. That means there are three windings. That means there are three pole pairs, north south and north south. So let's discuss how it works. Here now the magnet is in this condition. When we will give supply to A dash, that means switch S1 is closed, that time north and south pole will be created. This north and south pole will try to attract these both poles, and this permanent magnet rotor will align in the direction of A dash, and it will move 60 degree. That means in the from first position to the second position, this second position. Now if we have to rotate it further 60 degree, we will give supply to CC dash. That means we will switch off the S1 and we will switch on the switch S3. The supply will flow through the S3 through C dash and again back to the negative. So now the permanent magnet rotor will try to move in the CC dash magnetic axis direction. So it will rotate in the third position. Now it will align to the CC dash. If we have to move again by 60 degree, then we will switch on the B dash while we will switch off the S3 and S1. So when S2 will be on, the supply will move through the B dash and the permanent magnet rotor will try to align through B dash. So this is how it works. If we plot the table S1, S2 and S3, when S1 is off, that time it will rotate in this direction. When S3 will be on, then the second position to third position, and when S2 will be on, from third position to in this position, that is fourth position. So when we do continuously this, the brushless DC motor will rotate. Here we cannot do manual switching, hence we use the electronic component that is called as the inverter. Hence the DC supply is first given to the inverter, and then from inverter to the BLDC motor, and this total is called as the BLDC drive. There are wide applications of brushless DC motor. You can see they are used in compressor, refrigerator, in various devices. Now they are also used in electric vehicle, drones. So this is all about the brushless DC motor. Hope you would have understand the working principle and the construction of brushless DC motor. Thank you.